Welcome friends. In this video we are going to look at science, which is chemistry, and our focus is we just want to have a discussion of preparation of insoluble salt. Now before we look at that, first let's look at what a salt is. So what do you think a salt is? So if you look at the definition of a salt is defined as an ionic compound. Then if you recall from grade 10 work, an ionic compound is just a compound where we are expecting to have a metal and also the non-metal. Now in terms of the bonding that is found in ionic compound, we see that it is an ionic bond. The ionic bond involves the transferring of electrons. So it's a bond that is created between the two charges of different nature. Then for a metal, we know that a metal will form its charge by losing electrons. As a result, a metal will form an ion, what we call a cation. So remember, the cation is a positive charge. So under a salt, we need to have a positive charge, which is called an ion. Then for the non-metal, the reverse is true. Here we are going to have a gain of electron or electrons, and this one we are going to form an ion. Then an ion has a negative charge. So we can define a salt as it is just an ionic compound. So a compound that has a cation, which is a positive charge, and an ion, which is a negative charge. Now let's say we look at the preparation just for a start. Let's look at a soluble salt, and for instance, let's say we want to prepare salt which is sodium chloride, the table salt. So we are going to use, let's say we use a base plus an acid. So whenever we are using these of the same nature, which is in terms of the strength, if we have a strong base and a strong acid, this will give us a salt plus water. And we know that this is what we call neutralization reaction, because the two products are neutral. And let's take, for example, we use sodium hydroxide, which is in the aqueous phase, plus let's use hydrochloric acid, which is also in aqueous phase. So here we are going to have a double displacement. So the sodium will displace the hydrogen, giving us sodium chloride, plus the hydroxide will react with hydrogen, giving us water. Now if we are to break our sodium chloride into its ion, this will give us sodium plus in aqueous, then chloride minus also in aqueous. Now let's look at where the sodium came from in terms of the reactant. So we can see that the base contributed the cation, which is the positive ion. Then the acid contributes a negative ion. So a salt can also be defined as a substance that contains a positive ion from a base and a negative ion from an acid. So it can be defined as this. So the whole thing here is a salt is an ionic compound where we need to have a positive ion and a negative ion. Now before we look at the examples of insoluble salts, let's look at the table that should assist us to identify the type of salt given, because sometimes you may just be given a question, explain how you can prepare this salt. So the first step that you need to know is the salt that you're asked to prepare, is it soluble or insoluble? So the solubility of salt is very important whenever you're dealing with the preparation of salt. So the first column here, we are going to put soluble substances, including the salts. Then here we'll put insoluble salts or substances. So the first one will begin with the carbonate. So we want to know what carbonates are soluble. So carbonates of the first one, carbonates of sodium. So sodium carbonate is soluble, it dissolves in water. Apart from carbonate, we have potassium. Apart from potassium, we have ammonium. So the picture for carbonates, we can just say carbonates of group 1 elements are all soluble, including the ammonia. Then all other carbonates are insoluble. This is a very important table that I would like you guys to make sure you commit whatever that we are discussing into memory. So that is the first one with the carbonates. Now let's look at the chlorides, like salts that contains chloride, like we have sodium chloride, potassium chloride, calcium chloride, lead chloride. So now let's look at which chlorides are soluble and which ones are insoluble. So here we'll just say most. So we'll just say most chlorides are soluble, except we'll look at the first one, silver chloride is insoluble. So if whenever you encounter a question like it, explain how silver chloride is produced, just so that silver chloride is insoluble, even if the statement is not giving you that. Then apart from silver chloride, lead chloride is also insoluble. Then also mercury chloride is also insoluble. So these are the three salts that you at least see at this level. You need to make sure that you have in exception. Now apart from the chlorides, let's look at the nitrates. Now for nitrates, all nitrates, no exception, all nitrates are soluble. Sodium nitrate, potassium nitrate, lead nitrate, barium nitrate. So the key point here in general is all nitrates are soluble. They dissolve in water. Now let's look at away from the nitrates, let's look at sulfates. So sulfate will also go with the most sulfates. So most sulfates are soluble, except what sulfate are insoluble. So the first one, barium sulfate, is insoluble. Apart from barium sulfate, calcium sulfate is insoluble. Apart from calcium sulfate, we have lead sulfate is also insoluble. Then apart from that, even silver sulfate is also insoluble. Then these are the most one that we'll focus on for now. So we've looked at the sulfates that are insoluble and also that are soluble. Now, what of we just say sorts of? So say all sorts of sodium, potassium, ammonium are all soluble, no exception. Now let's summarize by looking at hydroxide. Let's look at what hydroxides that are common, that are soluble and also that are insoluble. So for this, we'll just say most hydroxides are insoluble. So except like for an alkali metal, so just say except sodium hydroxide is soluble. Potassium hydroxide is soluble. Or we can say all hydroxide of group 1 are all soluble. Then what else? Ammonium hydroxide is soluble. Apart from ammonium, also we have barium hydroxide is also soluble. So this is the table that you should have in mind, that should assist you on to identify if the given salt is soluble or the given salt is insoluble. Now, apart from knowing this, let's look at what method are we supposed to use whenever we are dealing with preparation of insoluble salt. So preparation of insoluble salt is formed by the process known as precipitation. So precipitation. So this is the method, and the salt that is produced, or a substance that is produced during the process of precipitation is called a precipitate, which is in most cases you find it as PPT. So a precipitate is just an insoluble solid that forms as a product in a reaction. Now, away from there, we need to look at some of the methods, how the preparation is done, then how can you separate those, you look at, you see the pattern, because the products during the precipitation, the products will be, one salt must be soluble, the other one must be insoluble. Let's look at maybe this equation to give us a picture. So whenever you are taught to look at the preparation of an insoluble salt, the first one that you need to know is you need to use two soluble substances. So in our case, let's just use salt. So soluble salt plus another soluble salt, then it will give us insoluble salt, the one that we want, plus soluble salt. So this is the equation formula that I want you to have in mind whenever you are dealing with the preparation of an insoluble salt. So remember, whenever you want to prepare an insoluble salt by precipitation, you need to use two soluble substances, which is two soluble salts. Then among these two products, one should be an insoluble salt, the one that you want, then the other one must be a soluble salt. So soluble salt must be in aqueous phase. So if you are looking at the states, because sometimes you may be given a question, write a balanced chemical equation including state symbols. So all soluble salts are written in aqueous phase, then insoluble salt is written in solid state, then here you have aqueous phase. So that is in terms of the phases. So now let's say we've formed this solution. In this solution, we have the soluble salt and the insoluble salt. So let's take these particles, the one I've drawn in bigger size, as our insoluble salt. Remember, insoluble, we are looking at those that cannot dissolve in water. Then we have the soluble. So the soluble is in solution. So after we've made this salt, now sometimes you may be asked, how can you separate an insoluble salt from a soluble salt? So what you just have to do is you just have to use filtration. Because if you pour this mixture here, we know that since the insoluble salt are in large particles. They will remain on the filter paper as the residue. Then the one that is dissolved, that is in liquid phase, will now be collected in this beaker here. So the method that is used to separate insoluble salt from the soluble salt during precipitation is filtration. So filtration, we know that filtration will help you to separate substances that are in particles, large particles, from a substance that is in a solution or a liquid phase. So we separate these two by using filtration. And remember, the insoluble salt, since they are in large particles, they will remain on the filter paper, while the soluble salt will now be collected in the collecting beaker. Now let's look at the first example. Okay, so let's say you are given to explain how you can prepare barium sulfate. So you are told explain, or maybe let's not focus on explaining. So let's just look at this. So barium sulfate is an insoluble salt. Then give two salts, give the two reagents that can be used to prepare barium sulfate. So these are the most questions that I see. So how can you know these reagents or reactants that you can use? So we have to look at this. So you need to have this in mind. Remember, if you look at the table that I gave you, we said most sulfates are soluble except barium sulfate. So barium sulfate is an insoluble salt. So whenever you encounter a question that is asking you to explain about barium sulfate, you are explaining on how to prepare an insoluble salt. So what are we supposed to do? So what you are supposed to do is, the first thing that you need to have in mind is, you need to use two soluble salt. So soluble salt plus another soluble salt, then it will give us insoluble salt plus soluble salt. Okay, so we have this in mind. If we have this in mind, what insoluble salt are we preparing here? It's barium sulfate. So let's do this. Let me write the barium sulfate here. Okay, so our focus is, we want to look at how do we know that the reactants that we can use are these. So your focus should be in what you are trying to prepare, and in our case we are trying to prepare the barium sulfate. Now barium sulfate is a metal, and the metal, we said, will form a positive charge. So the point is, you need to choose a salt from the reactant. You need to choose a salt that will have a barium in it, and make sure that that salt is soluble. That's a pattern. So which salt can you mention that will be soluble, that will contain barium? So the salt that we can use here is, let's say we use barium chloride. Because if you look at the barium chloride is a soluble salt. So from this barium chloride, our focus is just we just want the barium in this. Now we are done with barium. Let's look at the sulfate. So we need to choose another salt that has a sulfate in it, and that salt must be soluble. So what salt can that be? Let's choose sodium sulfate. Remember, all salts of sodium are all soluble. So this is the pattern that we use to that we need to use it whenever I did. So from the sodium sulfate, we'll get sulfate. Then from the barium chloride we get barium. So this is what you use to know the reagents or reactancy that you are supposed to use. So there will be a double displacement, and make sure as you are choosing those two salts that are soluble, make sure that the reactivity series of those two salts must differ. One must be more reactive, so that the most reactive will displace the other one. They will interchange. During that reaction, they will interchange, forming the substance that we want. So the substance, so since the sodium will get the chloride, here we are going to form sodium. Now, is sodium chloride a soluble salt or insoluble? It's a soluble. So we have it the way we want it. So that's the pattern that you need to follow. Now let's convert this one into a chemical equation. So barium has a symbol of Ba, and barium, according to my periodic table here, barium is in group 2. So it has a valence of 2. Chlorine has a valence of 1. So we are going to have a 2 here. Remember, all soluble salts are in aqueous. Plus sodium. Sodium is in group 1, valence 1. Sulfate is a radical with a valence of 2. That 2 will come here. Then we put aqueous. So remember, here we are going to have a double displacement where the sodium will displace barium. Then the barium will now take the position of sodium. So as a result, we are going to have barium sulfate. Now remember, barium sulfate is insoluble, so we put S here, plus then sodium chloride in aqueous phase. So what it means by double displacement is two have displaced each other. So sodium has gotten the position of barium because sodium is more reactive. So that's a pattern here. Now let's look at how can we balance this equation. So we can balance this equation. We need to check. So from the reactant side, we can see that we have only 1 barium. Also here 1 barium. Then chlorine we have 2. Then here we have 1. So let's try to put 2 here. Now this 2 is affecting both chlorine and sodium. So we have 2 atoms of chlorine, also 2 atoms of sodium. So our equation is now balanced. Okay, so we are done with the equation. So this is just the equation, but in terms of the explanation, you explain by saying the first step, number 1, choose 2 soluble salts. Number 2, make sure that the 2 soluble salts that you are choosing must have one cation. One cation will come from one salt, then the anion will come from the other salt. Then those two will combine to form the required salt. Now from there we have talked of separation. The separation is we can just filter. So we can just filter. So if maybe we can, let me see if I can make a picture here. So these two salts have been put in one system. So at first we have barium is bonded to chlorine. Then sodium bonded to sulfate. So this will take this position. This will take this position. As the result now, would find that after the equation, after the reaction, now our barium is bonded to sulfate. Then our sodium is now bonded to chloride. So this is the picture that we are trying. Then from there we can now separate as required. Now let's look at if we can write ionic equation for this one. So ionic equation, remember, you just have to consider those in aqueous phase. So remember, barium, Ba, is in aqueous. Now it has a valence of 2, so plus 2. Chlorine has a valence of 1, aqueous. So these two here should be written in front. Plus C. Sodium has a valence of 1. Also these two here must be put in front. Plus C, SO4 in aqueous minus C 2. Now the salt that is in a soluble, you don't have to break it into ions, so you just have to write it the way it is. Then for this one, we have to make sure that we do as required. Plus 2Cl minus. So this is just now the ionic equation, where we have the total number of the ions that we have that are present in this particular reaction. Now let's say if the question is net ionic equation. So the net ionic equation is where you remove the spectator ions. So the spectator ions are the ions that are in same state on both of reactions. So let's look at barium is in aqueous, then on the product is in solid, so it's not a spectator. Chloride is a spectator. Then what else? Sodium is also a spectator. So after you cancel the spectator, you can now finalize your final answer. So our net equation, you write what remains. So this is our net ionic equation. So this is the concept behind the preparation of soluble salt. Now the good part about the concept, this concept can be applied to any soluble salt. Let's have another example. Now let's say we want to, let's say, prepare a silver chloride. So the first question that we are going to ask ourselves is, according to the table that we looked at earlier, is silver chloride an insoluble or soluble salt? So silver chloride is an insoluble salt, so therefore we need to use the process of precipitation. So you can feel free and you pause the video and give it a try, so that practice, we know that practice makes perfect. So it's good sometimes you try it before you look at the answer. So our focus is we want to prepare silver chloride. So remember, the first step is we need to choose two reactants. So those two reactants must all be soluble. So we need two soluble salts to form the insoluble required salt plus C soluble. Okay. So remember, we said you should just focus on the salt that we are preparing. So we want to prepare silver chloride. So we are going to choose two soluble salts, in which one we are going to have silver, the other one will have chloride. So we can choose, let's choose silver nitrate. So if the question has not given you maybe the key on which to choose, you can just choose any, as long as they are soluble. Silver nitrate. How do we know that silver nitrate is soluble? We said all nitrates are soluble. So silver nitrate plus here, let's use potassium chloride. So say potassium chloride. I'm sure you can see what will happen here. So from the silver nitrate, we'll get silver. So this silver here. Then from the potassium chloride, we'll get this. So that is the pattern that I want you guys to have in mind. You choose two salts and make sure in each salt there is one of the ion that will form the insoluble salt. Then so we know that the potassium will displace silver, giving us potassium nitrate. So we are going to have potassium nitrate. Potassium nitrate is a soluble. All nitrates are soluble. So we still have this. Now let's convert this into a chemical equation. So silver, the chemical symbol for silver is Ag. It has typically it has a valence of 1, so we just put it like this. We are not going to enclose in brackets. Plus potassium chloride then we are going to have silver chloride solubles plus potassium nitrate in aqueous. Now we are lucky that our equation is already balanced. So how do you know, how can you tell that the equation is balanced? Whenever the reactants that are using, or maybe the individual elements that are involved, have the same valence number, in that you may have a balanced chemical equation. So now let's say we are also taught to write the ionic equation. So we can now break silver nitrate plus 1 equals the nitrate minus equals potassium plus equals chloride minus equals silver chloride. We just write it like this. Then solid plus potassium aqueous plus nitrate minus aqueous. So we have our ionic equation. Now if this is our ionic equation, which is just the overall ionic equation. So how can we now make the net? So the net is now where you cancel the spectator ions. So the spectator ions, we can see that nitrate is in aqueous, also here is in aqueous, so this is a spectator. So spectator ions that did not take part in a chemical reaction. So potassium is in aqueous, also here is in aqueous, so this is as well a spectator ion. Then our final answer will be silver plus aqueous plus chloride minus aqueous, then results in silver chloride solid. So this is what you do. So if with this information you can answer any question, as long as you master which salts are soluble, which salts are insoluble. So remember, you need to use two soluble salts, will give you insoluble plus the soluble salts. Then the separation, it's the filtration. So whenever you filter, the insoluble salts will remain on the filter paper, while the soluble salt will be collected as the filtrate in the collecting beaker. So these are some of the information that you can have whenever you are dealing with the insoluble salt. Now, before I end this video, I would like to maybe leave you with a question. So what I want you is, I just want you to try this one. Try to write an equation. So start by the word equation, chemical equation, ionic equation. If possible, describe how you can prepare lead chloride. So if possible, I would like to hear from you guys. You can write the answer or your explanation in the comment section below. So I want to hear from you guys. Then also, for those, I would like to ask for to be followed on TikTok. So on TikTok, you just search for Isaac Machiko. So that's it for this video. Thanks for watching.